Hello all, my name is Kirill Davidichev. I'm a solutions architect working closely with the EBS service team. And today I would like to talk about snapshots. So snapshots in a traditional storage environment can be thought of as just point-in-time copies of volume that are stored on the same array. You will see this a lot in enterprise SAN, enterprise NAS environments, where taking a snapshot is instant because ultimately it's just a file system construct. It can do copy and write or whatever. But a snapshot in a traditional storage environment cannot really be considered a backup. It's a very common interview question. It's, if your storage fails, your snapshot goes away with it. In EBS, that is not the case, and that brings a shift in how you should think about snapshots. So when you take a snapshot in EBS, all of the data in the background is copied to Amazon S3. The snapshots themselves can be either full or incremental, depending on what tier they're stored in. Standard snapshots are incremental, which means that as you take multiple snapshots of your particular volume, only the changes are synchronized to S3. And they are stored there in essentially a, I wouldn't call it a database, but they are stored using what we call chunks. So those chunks, if you really dive deep into EBS snapshots, can have a different block size to your actual volume block size. So it's important to keep that in mind. Because we store them in S3, we want to utilize S3's optimal size for objects. S3 doesn't really do well with super tiny objects. So the blocks are 512K in size. You don't really need to worry about it unless you use the direct API.
So is the snapshot instantaneous because it needs to be backed to S3, which can take time?
So yes and no. The snapshot itself, the API call is instantaneous. It takes an order of milliseconds, an order of seconds. And as you make that API call, you can also take take a multi-volume snapshot. For example, all volumes that are attached to the instance that will all be synchronized and crash consistent. But once the snapshot is taken, the actual process of copying it to S3 is not instantaneous. That takes time for a very large snapshot. It can take on the order of hours. And you have to wait for that process to finish until you can actually restore data from a snapshot.
So suppose if that process runs into some problem because it is a long-running job, syncing it to S3 can also have its own issues. I mean, like failures.
Sure.
So in that case, to the user, we have told that we have taken a snapshot, but actually the data is not backed up to the S3.
When you take a snapshot, the user gets a progress indication for essentially how much data has been copied to S3 for that particular snapshot.
Okay.
And until it is fully copied, the snapshot, if you look at it in the AWS console or if you look at it through the AWS API, it will appear as pending. So while the snapshot is pending, you cannot restore it. When it's pending, you will see the percentage, the progress indicator, and only as it reaches 100% will it show as completed and will allow you to actually restore the snapshot to another EBS volume.
So what's the redundancy for the S3? Is it based on how the bucket's configured? So
that's actually an interesting question. So even though we use S3 for snapshots, we use what we call a service-owned bucket, which means that you as the customer cannot access that S3 bucket directly. So to you, you cannot see what tier it's in, but it's using S3 standard, at least for the standard snapshots tier. And the durability of S3 standard is 11 nines. So 99.999 and so on %. S3 standard also is a multi-availability zone concept. So when John was talking about EBS volumes being zonal, the volumes they're constrained to a single availability zone. The snapshot itself is not. The snapshot is regional. It can survive a single zone outage, just like S3 standard can, and you can infer its resiliency based on the service contract, based on the durability of 11
So you
nines.
can restore to a different AZ.
Yes, and that is actually how a lot of customers move workloads between AZs. They take a snapshot and then they simply restore from that snapshot in another.
Will the volume properties be maintained? Like you said that the block size will be different for a S3 snapshot, it is 512K. For EBS, suppose it is 4K. So when we are restoring it to suppose a different AZ, will all those properties will be coming back, or it will be some default configuration?
The properties are essentially a volume level construct. So you can take a snapshot on a certain volume type. It gets copied to S3. It's stored in whatever way makes the most sense for us to store it in. But as you restore the snapshot to a volume, you can specify the parameters of the volume, whether you want to restore it to, for example, an IO2 or to a ST1, doesn't really matter. And you don't have to worry about the block size that we use for the snapshots unless you access them natively without restoring them to a volume.
Can you instantly mount a snapshot like that, or you have to recover it or restore it?
So when you create a volume from a snapshot, we use a term called hydration. What this means is the snapshot itself is mounted by kind of the backend EBS infrastructure, and it appears to you as a volume. But there is going to be a first-time read penalty if you start accessing it immediately after you create a volume from a snapshot and mount it. In order to get around it, you can either actually pre-read all of the data as the volume is mounted, or you can use a service we have called Fast Snapshot Restore, which gives you a fully hydrated, fully initialized volume as soon as you restore the volume from the snapshot. So to answer your question, yes, it's instant, but there is a performance penalty on reads until the data actually makes it back from S3 and into EBS. We have two tiers of snapshots today. So we have standard snapshots, and those, think of them as regular snapshots, right? They're stored in S3 standard, you can access them, you can immediately create a volume from them. We also have what we call Snapshots Archive. And the best way to think about Snapshots Archive is think of it as Glacier for snapshots. So like in S3, you have different storage tiers, right? You have S3 standard, which is designed for instantaneous access. And you have Glacier, which is much, much cheaper per gigabyte, but it doesn't offer you real-time access to the data. In the same way, Snapshots Archive, much cheaper than standard snapshots, 75% cheaper, but in order to get data back from Snapshots Archive, you first have to request a restore, and that restore will go to the Snapshot standard tier. It can take up to 3 days for you to actually get your volume back. So it doesn't make a lot of sense to use it for situations where you need to restore the data as soon as possible. We designed this feature for use cases like compliance, where customers have a regulatory need to store something for say 5, 7, 10, 20 years. And when we archive the snapshots, they become full snapshots. So standard snapshots, they're incremental. You can have 1,000 of them, and they will only store the deltas between the points in time for the volumes. When we archive a snapshot, We have to essentially fully hydrate it, and we store it as a. You can think of it as a single object in a lower S3 tier. So. Just keeping in mind there's store time, there's also a minimum retention period. They make a lot of sense for when you need to store them for long periods of time. They usually don't make a lot of sense for short-term storage.
Now, standard snapshots are incremental. So how do I know what the gigabyte per month is going to be for, let's say I take a snapshot a day or something like that. The first day is going to be a full, right? But the second day is going to be whatever changed in the last day. Is that, am I paying for the actual change data, or am I paying for the EBS volume that's being snapshot?
You're paying for the actual change data. Now, unfortunately, the system doesn't make it easy for you to determine what the changed data is
on a gigabyte per month basis.
Right. So you can do two things. You can either use what we call cost allocation tags to essentially itemize your snapshot costs and determine the rate of change by doing the backwards math from cost. Or you can examine the snapshots through our EBS Direct API, which has a API call called list change blocks, which will actually tell you what the delta is between the snapshots on a per block basis, as long as the snapshot
archive. It's a full hydrated version of the data that I'm paying on a capacity basis.
Correct.
So the archive could actually be more expensive than the standard snapshot.
It could be, which is why we have safeguards. So Snapshots archive, as a rule of thumb, makes sense if your rate of change between subsequent snapshots is greater than 25%. If it's less than that, it is cheaper to store the data in the standard tier. And Data Lifecycle Manager, for example, which I was going to talk about just now. So Data Lifecycle Manager is our snapshot orchestration utility. It's our UI-based scheduler. Really think of it as a fancy cron job with a UI. So it's a scheduler. It can let you set up multiple policies or schedules for any specific set of volumes. You can select them with tags. You can select them just by assigning individual volumes to a DLM policy. And Data Lifecycle Manager has the capability to do things like hourly, daily, weekly, monthly, yearly snapshots as part of the same job. Now, when we implemented Snapshots archive support for Data Lifecycle Manager, we realized that if we give customers a way to, for example, put their hourlies into Snapshots archive, that's a great way to shoot yourself in the foot from a cost perspective and so on. So Data Lifecycle Manager actually will not let you archive snapshots less frequently than once a month. You can have all sorts of schedules for your hourlies, for example, for your production systems, but it will not let you archive weeklies or dailies. You would have to do that manually through the EBS API.
Question for you on the snapshots. Yes. So, and this goes down to actually the implementation of a snapshot. Since you obviously can do operating systems, many different kinds of operating systems, right? Mm-hmm. You've got the Amazon Linux, you got all the different flavors, you got Windows, you got whatever. When you're cutting a snapshot, are you injecting drivers or controlling the operating system to a point where it flushes any writes that are pending?
Application consistency.
For the lazy writer within, let's say in Windows, before that snapshot's taken?
So no, we do not. The snapshots are crash consistent. Multiple volume snapshots are crash consistent among themselves. If
you have outstanding, if the application has written something but it hasn't made it out to disk yet, that's not consistent.
That's the difference between crash consistent and application consistent.
Exactly. Crash consistent is kind of an oxymoron.
Right. No,
It might come up.
kind of.
It might come up.
Yeah, so if you think of like a database,
Well, if you've got a journaled file system, if
Sure.
you've got a database, you're fine. But not all Windows has some problems with it in case.
yes,
Why
and
we have FSCK and these other things, right?
sure. And for Windows specifically, actually, Data Lifecycle Manager does not support it. But if you take snapshots using AWS Backup, we have our AWS Backup team here. It does have VSS integration,
There you
so it can actually make a application consistent snapshot. It's certainly on our agenda because, as you may imagine, it's a very frequent question we get from customers, and we would love to protect all of their workloads in an application consistent way.
Classic snapshot question.
When you're moving snapshots from standard to archive, how much time is typically going to be involved as that snapshot is moving? And if those standard snapshots are all incremental, and you've got 20 or 30 of them that it's going to comb through to rehydrate the copy to archive, how long is that going to take? Because I know doing that rehydration on backup appliances that are made by large companies in the Boston area can take large amounts of time. And I might have blogged about that occasionally. And so how painful is that going to be to move that data and move that stuff over to archive?
So we don't specify the actual speed at which the process happens, the process of copying data to the standard tier, or sorry, to the archive tier. But you can think of it as order of magnitude, maybe a terabyte-ish per hour per snapshot.
Okay.
So if you have a rather large, say, 16 terabyte snapshot of normal volume, you can expect it to be moved to archive in about a day.
Okay, that's reasonable.
It's very reasonable, yes, and it mostly actually depends not on the size. It doesn't depend on the volume. It's really an S3 thing. So we fetch the data from effectively the S3 service owned bucket, and we write it to another location in S3, which acts like Glacier in a way. All right. So Data Lifecycle Manager, yes, it's a snapshot automation utility, snapshot automation service. You can add things to Data Lifecycle Manager that deal with like a cross account or a cross region data storing. So within a schedule or within a Data Lifecycle Manager job, you can set up cross-account relationships. And you can say things like, when the snapshot completes, I want it copied to these accounts, or I want it shared with these accounts so they can pull from me. You can also do this cross-region, so you can have a Data Lifecycle Manager policy transfer data to another region for disaster recovery, for additional redundancy. And some customers also use it to synchronize their applications globally by just implementing AMI-based replication. An AMI is an Amazon machine image, which is essentially just a snapshot with a bunch of metadata associated with it. We just wanted to highlight some of the other data-related services that EBS Snapshots have. We have what's called Recycle Bin. And the Recycle Bin is essentially an undelete for snapshots. You have to enable it, but once you do, any snapshot that you delete will go into that Recycle Bin and will follow the Recycle Bin's expiration rules. That's important for environments where you can have potentially manual deletions. You've got admins accidentally selecting the wrong snapshot or the wrong chain, and then deleting it and asking AWS to undelete it. Before it was pretty painful. It's really designed for that and for any kind of protection against malicious actors, for example. So if somebody gains access to your account, even if they can delete your snapshots, if you have Recycle Bin enabled, they will just go into the Recycle Bin from where you can restore them. And you can also lock the rules for recycle bin. So you can say all snapshots will be stored in the recycle bin for 7 days, and you cannot change this rule.
What if they delete the account?
You can you delete an account?
Anybody with any rights can do whatever they want if they have the right.
I don't know. I haven't actually thought about it, but
It's the same question I had against
Sure.
things like unlike retention, just like regular retention lock.
Mhm.
Okay, or what if they stop paying their bill,
Right.
right? And Amazon decides, okay, you're no longer a customer because you don't pay your bill. I always wonder about that with these kinds of services. Is like, what's your standard policy, I guess, in those kinds of cases? And forget the account deletion, that's malicious, but also when, let's say you have a customer that decides, they're going to be a bad actor and not pay you.
I was just going to comment in the case of like a customer who didn't pay their bill, either intentionally or not intentionally, it goes through a whole life cycle.
Right.
So we're GDPR compliant with regards to when we delete all of the data, if it is a long period of time, but it first goes into a suspended state. And then it sits in that suspended state for some period of time where you don't have access to the data. But if you call up AWS and we set things up, it's all there, and we can re-enable it all. And then it goes from that suspended to the terminated based on kind of a governance policy.
Okay,
So it's not immediate at all.
that's solved. Now just the account deletion scenario is the.
all right. So sounds like even deleting an account will not get around the recycle bin rule lock, or at least not.
Well, that was not paying the bill. We don't.
Sure. I think there's similar safeguards when you delete an account, but I'm not sure what they are. I've never tried, to be honest.
Good to know.
So finally, there are workloads or there are use cases where you want to access the data in a snapshot without actually creating a volume from it. Two that come to mind the most is transfer of data into AWS or into a snapshot. A lot of our partners that do backups, for example, use Amazon Direct API's write capability to create snapshots from any source. So they can essentially take a volume, take a LUN, for example, from an on-premises storage system, via a snapshot on premises, transfer it over to AWS to an EBS snapshot, and then have that snapshot be restorable as a volume. So EBS Direct APIs gives you the capability to write not just to a new snapshot. You can also write kind of a delta on top of an existing snapshot. So you can also use Direct APIs as a way to do like not real time.
Are you talking about
asynchronous
Outpost
replication.
here, or are you talking about Linux or VMware?
Doesn't matter.
Say that again. I'm sorry.
Are you talking about, so when you do a snapshot from the cloud to on-prem or on-prem to the cloud, are you talking about, it's AWS Outpost, it's an on-premises version of AWS infrastructure, right?
Yes, it is. It is.
Are we talking only about AWS Outpost?
No,
Or I'd be running VMware taking
it could be
a
from any
AWS
system.
snapshot?
From any system. So I could take my laptop here, run a utility, and upload the contents of my drive to an EBS snapshot, and then take that, attach it to, for example, an F1 Mac instance, and assuming there's no issues with the operating system,
yeah,
that
snapshot,
thing
you're
should
actually
boot right up.
copying the data from my volume sitting on my laptop to
You can do that, yes.
a snapshot, quote unquote, sitting in EBS or S3.
So you can do
Different
that. Yes, you can ingest data from, say, a hard drive. You can ingest data from a tape if you want, write it to a snapshot, and then have that data appear as a drive in the cloud. You can also read from Direct APIs, and a lot of the use cases that we see on specifically reading. There's of course replication. So just like writing, you want to get your data into the cloud, you can copy a snapshot back on premises and restore it to, for example, a local disk, if you wanted to. We also see some security-related partners that use the Direct API's read capability for scanning of things like malware. So those are really the two major use cases I see. The third one, and you will see here, so you can compare snapshots and rechanged blocks. That is what I was talking about earlier. So you can gain visibility into your deltas. You can use the direct APIs to measure your daily rate of change or weekly rate of change, for example. And you can use that data, so what you got from the changed block tracking, to determine if your snapshots are good candidates for archival, for example. So you can figure out if it's over 25% delta, yes, let's archive it. If it's not, keep it in standard. And a lot of customers have automated tools that will do this on a per snapshot basis. They will potentially log the total capacity of a snapshot as a tag on the actual snapshot, and keep it for their internal visibility use cases. So, a customer example, Johnson & Johnson, they went through essentially exactly that process. They had 120,000 snapshots that they needed to keep for, I believe, up to 20 years in their case, because of regulatory reasons and so on. And they went through a process of determining which snapshots they should archive. They ended up archiving 120,000 snapshots, about 3 petabytes of data. And at their scale, they saved about $1 million a year just from the snapshot costs alone. So they worked with our Lambda team. They set up some Lambda-based serverless automation to determine which snapshots are good candidates for archival, and they've archived them all.